GM. Happy to see you here. We're kicking off the last open office hours session that we've planned for this week and for the bootcamp so far. It's focus going to be on the Expander Toolchain, and we will be happy to take any questions you all have regarding the things that you're building, questions that you think might come in handy. That doesn't matter if that's going to be for you, for someone on your team, or the cohort in general. So feel free to use the chat section. Feel free to raise your hand and mute. Again, I will be happy to see some smiley faces on the other side. So feel free to turn your cameras on as well and make this as engaging as possible. We have an hour, so loads of time to go over things. And yeah, I'll give the word to Zhenfei from the Polyhedra team. We have multiple representatives. Maybe Zhenfei, you can present the other participants, and people can start asking questions afterwards.
Yeah. Thanks for the intro. And okay, hi, good morning, everyone, and good afternoon or good evening. So as you know, this is Zhenfei. I'm coupled with Eric from our team, and also Zhiyong Fang, who had taught a session about the backend, Expander backend, 2 weeks ago, and also Tony Su here, who's also our backend engineer, who has been working on the Expander proof system as well. So together, three of us are the engineers who are developing the Expander system, and Eric is more on the strategic side for us. So we are here to host these office hours. We do not have a particular agenda, unlike the office hours last week. So this time we are here to basically to go through any questions that you might have already during your experience with Expander, both the front end and back end. So maybe you can start it there. If you have any questions, please feel free to post it on the chat. While we're still waiting for the while we're still waiting for the questions, maybe you can recap a little bit about the hello. We can recap a little bit about the Expander proof system, like how do you use it, etc. So I guess in the previous sessions you have already there was already 2 sessions about A, the Expander compiler collection, and B, the Expander proof system itself. The second one is taught by Zhiyong here. I guess just try to recap. So when you start with your project, you want to use the you want to firstly maybe say if you want to build a Fibonacci, if you want to build a proof for the Fibonacci proof system for the Fibonacci computation, you want to say abstract the statement that you actually want to prove first, and then you use the Expander compiler collection to write your circuit. Basically, that's a toolchain that's very close to the GNAC system. If you are familiar with the GNAC, or someone call it GNAC, you will be able to write the similar logic. You will be able to reuse most of your Go code there, and then convert it to the intermediate representation that's useful by the. I see more people coming in, so let me just try to recap. So this is an office hours for the Expander toolchain. So feel free to post any questions. I'm here to. I mean, at the moment, I'm just recap what we have been going through for the last 2 sessions around the Expander proof system. But please, if you have experience any questions or issues during your programming with Expander, please post it, or even feel free to share your screen. We can help you to look at the code. So getting back to the the building procedure with, oops. There was a question. Can you explain more about the GKR recursion? What would be ideal project delivered with keywords that we should try while building it? Okay, I'll explain this in a second. Let me finish. Let me quickly finish what I was talking earlier. So suppose you want to write a Fibonacci proof, then you extract the statement there. You use the Expander compiler collection to build the IR, to build the intermediate representation, right? That will generate a circuit, and as well as the witness that you are using for your statement. And next, you plug those two binary files or TXT files to the expander. There was an example under the GKR man.rs. This will show you how you can. This will let you know. So you will be able to see how you can actually convert the circuit and witness into the proof from that. Basically, that will be the end-to-end workflow. Then you can test locally that this proof is correct or not, and then you'll also be able to use the recursion to show to make this proof on chain. Now, let's get back to a question. So first would be the GKR recursion. Can you please can you please elaborate what exactly was the question? I mean, I didn't really follow what would be the ideal project.
Maybe Zhenfei, maybe we can share some project ideas that would benefit from utilizing GKR recursion.
Oh, I see. Oh, that totally makes sense. Okay, there are like many projects that can benefit. I guess one of the very typical example is this accelerating the ZK VMs. Say suppose all these ZK rollups. So at the moment for these ZK rollups, the main bottleneck for them is to prove the state transitions between different blocks. And the state transitions consist mostly of the K-check circuits or the hash function hash circuits. And as you know, that expander is very fast for the K-checks, for the hash functions. It is not so easy to replace, or I should say, it's a lot of engineering effort if you want to rebuild everything from scratch. But if you say, okay, I prove all the state transition in expander, and then in my whatever proof system that I'm currently using, I can just recursively verify this expander proof, and then that implies that the original state transition is correct. So combining these K-checks, so I would say that the recursion would be very useful for you to combine the expander system with any existing ZK VMs, so that you can have both the speed from the expander, also the already integrated system from all the ZK rollups. Okay. Then the next question would be, should GKR be built from scratch with other brands, or build something with expander, GKR plus Libra, or modify something using the Toolchain? The expander is an implementation of the GKR protocol. Actually, expander is an implementation of GKR plus Libra protocol. So if you are talking about GKR recursion, then yes, you probably will need to build most of the things from scratch. But probably you just need to write the circuit using the expander compiler collection. You don't really need to re-implement the GKR protocol itself. Our hope is like you use the existing toolchain and then build the recursion.
Yeah, I will just add on to that we have done a lot of the legwork on the building out the expander compiler collection, and really we're looking for the teams that are going to be able to put that into practice and kind of build on top of that. So definitely don't go and reinvent the wheel here. We've done a lot of the work for you that should make development easy. But as you guys are working, if there are things that you're trying to accomplish that are difficult or you're unable to do, please do provide us that feedback so that we can make improvements.
All right, let's move. Although Zhiyong and Tony, feel free to chip in if you have any thoughts. Okay, I'll move on to the next one. the next question is, I've been interacting with Expander Circum preprocessor library to connect to convert my circuit to Gnak and work with the circuit in GKR in Go. But I noticed that there's a logic that is not processed correctly. I noticed that the Circum preprocessor is from version 0.03 and it's not available in 1.0.0 of the Expander. Is there any problem with using it at the moment? I'm currently rewriting circuits from scratch in Rust in Expander due to this problem. So, okay, as far as I know, there was the support for Circum was there was a support for Circum in a very early version of the Expander, but in the recent release we removed that support. So yes, I mean that's the right behavior. Like the version 1.0, you won't be able to use your Circum. You won't be able to write in Circum and then use our compiler to compile it. You have to use the Rust or the Gnak front end. Okay. Next question is about the ZKML. So, are there any integration with ECC with the ZKML framework? Does ECC support front ends other than Gnak? Okay, those are two separate questions, I guess. First, for the ZKML framework, yes, there is a toolchain that is built on top of ECC. So this toolchain is called ZK PyTorch. We have written a tutorial which show that which gives you a basically end-to-end workflow of from starting from building your own model to generate to extracting the ONNX IR and then to feed it to the ECC and then use the ECC toolchain to generate proof. So all these toolchain we have already built. I guess we are on the final phase of the open sourcing this ZK PyTorch from this ZK PyTorch thing.
So there's a follow-up question that says ZK PyTorch is not available right now. Is it? Can we?
Oh
Can we give people a ETA on when we expect that to be available?
It's getting signed off today, so I'll post the. It's getting signed off today. That was today. I apologize for that. Should be ready in a couple of days.
Amazing.
All right. Does ECC support front ends other than Gnak? We have another front end which is in Rust. But it uses very similar syntax as the ECC. At the moment, we do not support other front ends. Oh, actually, sorry. There was a third front end which is in-house, which is at the moment developed, which we are currently developing, which is called ZK CUDA. This ZK CUDA front end is, I think the code is there, but it's not. It's not as mature as the existing ECC in a sense that it hasn't been really heavily tested or audited.
I think we have some examples about the where you can test build and test some simple circuit. Framework will help. Would help you to better organize all the circuits. So it's like more than a large single circuit, but a collection of circuits proving process with the ZK CUDA. But yes, that's true. As Zhenfei said, it's not as mature as the one we've brought to you. Yeah.
Okay. Maybe we can send a link to the document of the ZK CUDA here. I'm trying to find it. Zhiyong, do you have it?
Yes, I think so. Let me
Okay.
Find the link. You can go on with it.
Okay. All right. The next question is about the ZK-based routing wrapper with recursive proofs. There's a let me try to read it. Is it feasible or good use case to build a wrapper around HTTPS requests such that we partially unwrap proofs until the intended verifiers can respond to it? The goal is to ensure the routing MAC stays hidden and that a connection can be established in a random manner over several on-chain rounds. Maybe even add another sub layer in session TP layer. Another use case would be to use it as a VPN instead, but then that leaves us with the exist node being able to decode the info and receive a response that's not somehow ZK sanitized. I would be very thankful for your insight into something like this. And by the way, we've decided on another project as team, but I was just curious about a use case and a problem for something like this in the context of privacy. Okay, I guess this is a more general question. It's not necessarily ZK recursive proofs, right? Because what you are describing here is a typical use case of the ZK that delivers some privacy mechanisms over the So there was a project with there was multiple projects that's building ZK-TLS. Probably that will be the thing that's very close to what you are describing here. I would say that in general, that's a good use case of ZK tech. Yeah, like in yeah, I would say that's a good use of ZK. I guess the only thing here that on top of my head is like, how do you verify it? Like in the in the Web 2, like all these TLS, you have certificate that's been you verify the certificates, right? And then the certificates, there's a root of trust for those certificates or the CA, right? Where in here in your use case, I'm not sure how this will work out. Maybe you will need to write a host spec, or maybe this gets verified on chain. And then if it does get verified on chain, then you probably are looking at a huge amount of traffic, which makes the scalability an issue. So I guess my suggestion would be first spec out your whole protocol, try to see where the actual bottleneck is. The ZK tech can work here, but I guess the tech allows you to do it, but I'm more worried about the scalability. There was a question about how could I use Polyhedra network to build a platform that manages user deposits similar to Polymarket. I'm not sure I understand the question. I mean, actually, I'm not very familiar with Polymarket. What APIs could we integrate? So I guess if you are talking about our own layer one, so we have a layer one called EXP chain. If you are talking about that, then it's a EVM compatible chain. I guess you can just the APIs are standard. I mean, by the way, this is way out of the scope of this bootcamp. But if you are interested in deploy anything on the expander, also on the EXP chain, you will be able to use a standard API. Yeah. Okay. Got it. So Polymarket is built on top Polygon. Yeah. So that again, that's not a expander related question, but if you were to build it, you should be able to use the similar APIs. Like the EXP chain is a EVM compatible chain. All right. I think we've gone through the questions so far. I see like most of people are still very interested in the in general of how or what can be used with the expander. Okay. There are two more questions. Sorry. The first one would be, can you share judging parameters? Most of the resources available are papers, but it would be nice to know expectations. Okay. Last week we've had four four office hours. We invited four moderators from the tracks. They shared their thoughts on what qualified as a good or great or winning submission. For example, in the private transaction session, we specifically said that okay, for a successful transaction, for a successful submission, it must be firstly feature complete, meaning that you actually did a private transaction. There's no leak of information. Then he thinks that you need some on-chain verification, and also some wallet integration. Although the on-chain verification part is not a part of the judgment, but in order to have end-to-end, you will need to be able to initiate a transaction from your wallet and then get it maybe verified or locally. Doesn't really need to be on-chain. And then there are like three different algorithms in the in private transaction. There was a mint, which means you build you generate a private token, and then there is also transaction, and there is also forfeit, which is to convert the private node into a public node. And he was saying that for a qualified submission, that this needs to have the mint and forfeit function, although the transaction function may be, a transaction function would be optional, but it's also a bonus if you can get it. And then, so those are that maps the feature completeness, right? And on top of that, he also wants the performance in a sense like a winning submission would have a better performance compared with others in terms of proving, right? So using expander, so if you have a better circuit than others, then you are more likely to win. So that's just one typical example of all these office hours. So I would encourage you to watch the rest of them. So if there is a specific session, so a specific track that you are interested, just tune into that book to that office hour and see what the moderator says. And just try to be clear. So we are not the judge. We means the Polyhedra. So we are hosting this bootcamp, but the judge, we want to be credit neutral, right? We don't want to pick winners. The moderators of each track will decide who are the winners, and depending on their discretion, there can be multiple winners, splitting the whole bonus, the whole reward. And the moderator will judge who are the qualified receivers of the rewards. Can you use next question? Can you use Polyhedra network with Trust Wallet or MetaMask? I'm not sure what's the status of the integration. Maybe Eric, you have some idea here? Or?
Yeah, if you go to can use Polyhedra network with Trust Wallet. Yeah, so if you go to bridge.expchain.ai, we've integrated with Dynamics wallet SDK, which allows you to log in with your wallet of choice, or even create an account with your Google login. So yes, the answer to that is yes, but also, again, a little out of scope for this. I will say, maybe I'll give a teaser that following the Expander hackathon and bootcamp, shortly after, we were planning on launching another hackathon and bootcamp that will be focused around EXP chain and development on top of EXP chain. So I'm really excited, Enrique, that you're enthusiastic about developing on EXP chain. And we will have an opportunity for everyone that is excited about EXP chain to do so. So stay tuned for that.
All right. Okay, people, please pop in your questions. Or maybe anyone wants to share.
Maybe I know I see Zhiyong posted the simple example link above. Maybe we can, if there are no other questions, maybe we can go through that and kind of just walk through, exactly what's going on step by step there.
Sounds good. Sounds good. Sorry, Zhiyong, not trying to put you on the spot, but do you want to go through this example?
Oh yeah. Let me. I suppose I need to share the screen. Let me close some relevant. Can you see my screen?
Yep.
Yes, now we can see it.
So we can probably go through to have a general idea about how the ZK CUDA works. So you have different components of the circuit. I think usually different components of the circuits and put them together, but things becomes a little different. Since we no longer have a single, since we no longer have a single circuit, but have two here. One called kernel add2 and the other kernel 16. You can treat this as two independent. So the add2 function here add two inputs of the, as the name suggests, add and produce a single output. And then the add 16 here is similarly, as the name suggests, add up all the values input. So thing here is you can introduce 8 groups of add2, and then you can introduce 16 groups of add2. So in total there will be 32 inputs, and we apply kernel to the 32 inputs, producing output of 16. And then we can apply the single output. You may be wondering what's the difference between this one and constructing a whole large circuit. So the difference with these kernels, we can call the proving system like we call CUDA kernel. For the add2, we can call the proving system with some parallelization. So remember there are 16 add2 kernel here. So a system with a parallelization of 16, because 16 Then we can call the proving system with for the kernel at 16 with a parallelization of number 1 at 16 circuit to add a circuit. So for the detail of how to write circuits, you can refer to this example context here to organize all the yeah. So yeah, that's basically the yeah. Do you have any?
Thanks, Zhiyong. Yeah, I guess. Oops. So if you are new to the Expander and you want to write code, write your circuit, and I would try to. I guess actually I would suggest you to use the ECC to rather than ZkiCuda, as ZkiCuda is as I was mentioning earlier, it's still experimental. Though I think this will be the future, we are still in the phase of completing the features and make it more robust.
Yeah. May I chime in for a few minor explanations and minor motivation explanations? So I would like to add one thing to the naming, which is why it's called ZkiCuda. Just think about the computation you're trying to prove. It's kind of like a graph, and you can decompose the whole computation into different nodes. And this is very similar to the CUDA programming, which is you have a bunch of kernels and you have a bunch of subcircuits, which you can separate down the large circuits into small subcircuits. And that's why we introduced the concept of kernel, which is Zhiyong previously mentioned. And this sort of analogy matches to from the CUDA computation to the ZK proving. So that's why it's called CUDA, and we actually borrowed a lot of concepts from the CUDA programming, and that's why the keywords and the naming sort of collides to each other. But still, yeah, adds back to what Zhenfei just mentioned. Yes, this is still very experimental, and if you still have a very large circuit that's hard to decompose, or sort of you don't have in mind how they have to be arranged, just go to ECC, and that should be the way to go for now. That's all I have for now.
Thanks, Tony. Okay, let's see if we have other questions. Or maybe Eric, you have other things you want to share or for us to elaborate?
No, I think this was a really informative session. I think, if there are no other questions, we can kind of do a last call for questions. I will just reiterate that, we will make ourselves available in the Polyhedra Discord, and also I will be popping over to the Encode Club Discord as well to answer any questions that you guys have. So encourage you guys, if you haven't already joined, to do so. You will need to authenticate and get a developer role, which will require you to log in with your GitHub, and then you can join the channel Bootcamp, where I will be, Zhiyong, Zhenfei, Tony as well. And we are available. We have all different working hours, so one of us will be around to kind of answer your questions. And as you guys progress, we're happy to kind of give feedback or even just kind of go back and forth on your ideas and make suggestions if that's what you would like. So yeah, I think with that, we'll give everyone a minute or two to post any final questions. Otherwise, really thank you for the engagement and all the thoughtful questions. I think this was a really good session, and we'll post the recording if you want to come back to this later.
Yeah, as Eric mentioned, everybody, we are quite active. I myself and everybody on the Encode team can pretty much cover the Asian and European time zone. We're quite active. And then the Polyhedra team is quite active in the US time zone. So regardless of when you end up posting, there's going to be someone that will be around to help you out with questions. I'm going to quickly post a link, which is a collection of all the workshops we've had so far, missing this one, obviously, which we will add to that list in the next 12 hours. I strongly encourage everyone to go through the workshops that we've had, as well as the open office hour sessions we've conducted, because these, like the first one's a bit more theoretical, while the open office hours have focused more on the things you can build. As you've asked today as well, ways to stand out and make an impression with the project that you are building. There's lots of support to go around. A reminder for everyone, we've sent multiple links. This Friday, we will be expecting you all to submit your idea, the thing that you are planning to build on. Again, this is mandatory in a way that we want to know what you're building, because this helps us with providing you all with the right resources and connecting you with the right people in order that all of your questions end up being answered, and we ensure that your journey from idea to a project submission ends up being a successful one. So don't be shy on sharing some details, even if they're not fully finalized. We just want to have a general idea of what you're planning, and we will be taking it up from there, reaching out to you, helping you out, and offering support where needed. I'm not seeing any more questions, so I think that this is going to be the end for today's workshop. I can see people joining now, but sadly we are rounding things up. And thank you all for all the sessions and participation so far. And see you all online on Discord. Make sure to read the end of week kind of summaries we're sending to all of you. These are nice wrap-ups of everything important happening, as well as information that we want you all to have and keep in mind. And other than that, look for us on the Discords, both the Polyhedra Discord as well as the Encode Discord. Post your questions, be active. We're always there to help. Thank you all. Thank you, Zhenfei, so much. Thank you, Eric, for the constant support. Thank you, Zhiyong and Anthony for popping up on this one as well. And yeah, wishing you all a great day. This was a great session, and looking forward to the next few weeks of building.
Thanks, everyone.
See you all.
Thank you.
Have a great day. Cheers.